হ্যাঁ এইটা
আচ্ছা 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 আচ্ছা, ঠিক আছে ঠিক
ঠিক
আছে।
আছে,
এখানে
বেশ 3টে থেকে শুরু হোক, আমি মাইক্রোফোন খুলছি।
ঠিক আছে। অনুপম, অনুপম,
ইয়েস স্যার।
বলছি যে রেকর্ডিংটা করবে তো?
রেকর্ডিং করবো, রেকর্ডিংও করবো। রেকর্ডিং যখন এটা স্টার্ট হবে প্রোগ্রাম তখন থেকে রেকর্ডিং শুরু করবো।
ঠিক 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 আছে, ঠিক আছে।
আর ওই ইয়ে নেই তো আগের দিকে, ন্যাশনাল অ্যান্থেম নেই তো?
না 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 না।
ওকে।
Good afternoon to one and all. On behalf of the organizing committee of AIAMLCC 2023, myself, Shubhabrata Barman, Assistant Professor in the Department of Computer Science and Engineering, Haldia Institute of Technology, welcome you all to the one-week faculty development program on artificial intelligence in advanced machine learning and cloud computing, AIAMLCC 2020. AIAMLCC 2023, organized by the Department of Computer Science and Engineering, to be held from 10th to 14th July 2023. So AIAMLCC 2023 is a intensive one-week faculty development program, which is being organized for faculty, research scholars of engineering and technological institutions. It is also open to persons from research scholars. It is also open to persons from industry. The objective of this FTP is to present a clear understanding for today's technologies based on next generation smart computing paradigm. Prominent interactive sessions with experts will be conducted in different domains of research, such as cloud computing and its services, fog, edge computing and its applications, Internet of Things, big data and analytics, artificial intelligence, and many more. The technical program will include state-of-the-art lectures, discussion, presentation sessions, specifically focused on the insights, research challenges, and probably hands-on sessions in the said research areas. The participants from academics, industry will be benefited immensely. This will guide, learn, and carry out research activities. To impart knowledge to the participants pertaining to theoretical as well as analytical treatment to the problems. By doing this FDP course, participants will learn to develop a smart system incorporating the trust areas and will learn about applications that may ease our day-to-day life, day-to-day real-life activities. The user will also adapt new trends of accessing and retrieving the data and analyze it from a remote location where he or she gets smart concepts offered. The objective of this course is to provide an opportunity for researchers and practitioners from academia and industry to gain insights into the developments along with the existing research challenges in these domains, as well as a practical exposure to effective smart systems, tools, and related applications. So today we have as our speaker Dr. Sriporna Shaha, Associate Professor in the Department of Computer Science and Engineering, IIT Patna. I would now invite Dr. Shubhankar Juardar, Professor and Head of the Department of Computer Science and Engineering, and who is also the Program Chair of the MDP, to deliver his inaugural talk. Over to Dr. Juardar.
Am I audible, Professor Barman? Hello? Am I audible?
Yes, sir, you are audible.
Okay, thank you. Thank you, Professor Barman. First of all, I would like to thank our Chief Patron, Haldia Institute of Technology, Dr. Delete, Dr. Lakshman Chandra Seth, Chairman of our ICARE, Haldia Institute of Technology as well. I would also like to thank our patrons, Mr. Ashish Lahiri, Secretary ICARE, Mr. Shantan Seth, Vice Chairman ICARE, Sudiptan Seth, Assistant Secretary, ICARE Haldia. Our advisory committee, Dr. Professor Subroto Mondal, Principal, Haldia Institute of Technology. Dr. Anjan Mishra, Registrar, Haldia Institute of Technology. Dr. Torun Kanti Jana, Dean, ACCI, Haldia Institute of Technology. Devashish Das, Administrative Manager, Haldia Institute of Technology, and the organizing committee. My special thanks to Dr. Pinakipati Acharya, Professor, Department of CSE, Professor Shantanu Kole, Department of CSE. Thanks to Professor Shubhabrata Barman for organizing this, and the luminaries and the speaker, those who are presenting their valuable talks, and they give their valuable time for this 1 week faculty developed program on artificial intelligence and advanced machine learning and cloud computing. First of all, I would like to thank Dr. Sriparna Saha, Associate Professor, Department of Computer Science and Engineering, IIT Patna. She has consented us and given us a time from his busy schedule. Her topic will be multimodal information processing application to the real life problems. Second, I would like to thank Sanjay Kumar Panda, Assistant Professor, Department of Computer Science, NIT Warangal. Third, I would like to thank Professor Shubhra Sarkar, Principal Consultant, Cloud, Tech Mahindra. Next, I would like to thank Dr. Sheikh Arif Ahmad, Assistant Professor, School of Computer Science and Engineering, XIM University, Bhubaneswar. Dr. Devi Prasad Dogra, Associate Professor, School of Electrical Science, IIT Bhubaneswar. This FDP is actually, we try to equip the various practical sessions and the visualization techniques and expose them on challenging issues of AI, ML, and the cloud also. The participants, I suppose, you will be much more benefited after these 5-day long sessions in this 1 week faculty development program. I will not take much more. I want to give it to Sriparna Saha Madam because all the participants, they are eager to learn from her. Thank you, all of you. Thank you, participants. Thank you, speaker, my organizing team, my advisory committee, our patrons, our chief patrons, and all. Thank you. Thank you, all of you.
May I have a small introduction about our esteemed speaker, Dr. Sriparna Saha. Dr. Sriparna Saha is an associate professor in the Department of Computer Science and Engineering, IIT Patna. She received her MTech and PhD in computer science from the Indian Statistical Institute, Kolkata, in 2005 and 2011, respectively. She has authored or co-authored more than 400 research papers. Her current research interests include deep learning, natural language processing, machine learning, information extraction, text mining, bioinformatics, and multi-objective optimization. Stanford University, in a survey, also listed her as one of the top 2% scientists in artificial intelligence with more than 5 published papers. She's the associate editor of several reputed journals, including IEEE Transactions on Computational Social Systems, IEEE ACM Transactions on Computational Biology and Bioinformatics, PLOS One, Pattern Recognition Latest, Expert Systems with Applications, Neurocomputing, ACM Transactions on Asian and Low Resource Language Information Processing, etc. Her current H5 index is 37, and the total citation count of her papers is more than 7,187, according to Google Scholar. She is the recipient of several awards and fellowships, including the ACRB Women in Excellence Award 2018, Google India Women in Engineering Award 2018, NASI Young Scientist Platinum Jubilee Award in the year 2016, the field of electronics, computer science, and engineering, ISIAA Rashi Ray Memorial Medal from the Indian Statistical Institute, Kolkata, for being adjudged the first class first in MTech examination in computer science in the year 2005, Humboldt Research Fellowship, 2015 CNRS Fellowship, etc. So with that, I would hand over the session to Dr. Sriparna Saha. Over to you, madam.
Yeah, I hope I am audible.
Yeah.
Yes, yes. Okay. Yeah, many thanks for this introduction, and many thanks the organizing committee of this FDP on AIAMLCC2023 by the Department of Computer Science and Engineering, Haldia Institute of Technology. So yes, many thanks for inviting me in this particular FDP. So today I will discuss about multimodal information processing, and then I will show some applications of this multimodal information processing in real life problems. So these real life problems are selected are basically related to natural language processing. So I will show their applications.
Just a small introduction. Could you
Yes,
please
yes.
make it full screen?
Oh, it is not full. It is not showing full screen.
No.
Okay. Then maybe I need to share the
Share it
inter screen maybe. Okay. So is it now? Is it full screen?
Yeah, madam. It is full
Yeah.
screen.
Okay. Thank you. So yes. So basically, initially I will discuss about multimodal information processing. What is the significance of that, and how can we fuse information collected from different modalities? And then I will discuss about some application domain. So yes, I am currently an associate professor in the Department of Computer Science and Engineering, IIT Patna. So my research group at a glance. So basically, IIT Patna is established in the year 2008. So it is the second generation IIT. Now there are 23 IITs in India. So basically, government of India has almost in each state there is a IIT, and IIT Patna is situated in Bihar. So here there are 10 departments in IIT Patna, and our the Department of CSU Computer Science and Engineering is basically the offering 2 BTech degrees, one in computer science, another in EI and DS, and we are also offering MTechs in CS, in artificial intelligence, maths and computing, etc. And there is also a PhD program in computer science and engineering. So in general, my research areas are natural language processing, deep learning, machine learning, etc. And mostly in recent years, my focus is on multimodal information processing. So our idea is that not only we should rely on text data, but also the image data, audio data, or video data. Because in many cases, like for example in social media, people are often, they are basically not only writing the text data, they are also uploading images or the videos or the audios. So yes, these are the some publications from my group, and also that already 12 students have graduated under my guidance, and another 12 are currently pursuing their PhD. Yes, so coming to the today's talk. So yeah, artificial intelligence, basically is a very popular branch of computer science that concerns with building intelligent smart machines capable of performing intelligent tasks. So basically, somehow in an artificial manner, we want to inject intelligence into a machine. So in general, a computer system is not, it's basically a machine only. It doesn't have any intelligence. But if somehow we can inject some intelligence into a machine, then that is called the artificial intelligence. So with rapid advancements in deep learning and machine learning, the tech industry is transforming radically. So there are several disciplines under artificial intelligence like machine learning, deep learning, etc. So machine learning is basically a tool or a technique by which we can make the machine intelligent enough. So it is a type of AI that enables machines to learn from data and deliver predictive models. So basically, based on the data only, it can extract the patterns from the data, and it try to understand the problem statement. So basically here, you do not have to give the algorithm to solve a particular problem to a machine. So you give enough data related to the problem statement to a machine, and the machine will automatically understand the algorithm. So that is the uniqueness of machine learning. So now data is the fuel, data is basically the oil. So you only have to give enough data to the machine, And now from the data only, the machine will understand how to map input to the output. And that way, basically, this is the the beauty of machine learning, that is the difference between the traditional programming and the machine learning. In traditional programming, the user has to write the program, means the algorithm has to be given by the user, and also the input data has to be given. And now this input data can be applied, and the algorithm can be applied on the input data, and the output can be generated. But in case of machine learning, the data is the input, and now it will automatically learn how to map the input to the output. So basically, that is the advantage of machine learning. So, and the deep learning is basically a subfield of machine learning that is concerned with algorithms inspired by the brain structure. So basically, in our brain there are several neurons, and basically deep learning is somehow following this neuron structure. So these are called the artificial neural network. So a computer model can be taught using deep learning to run classification actions using pictures, text, and the sound as input. So now that AI is having applications domains. Like AI is having applications in economic empowerment, in infrastructure building, in environment, in crisis response, equality, then information verification and validation, health and hunger, education, public and social sector. So in many sectors, AI is having application, and that way we can be easily able to establish an infinite affinity with common people of the society. Like as AI can be applied in various sectors, so maybe, and these tools and techniques can be easily deployed for the societal uses. So by this, AI can easily establish some infinite affinity with the common people of the society. So, in recent years, United Nations has identified 17 sustainable goals, which is called the SDG. So, like this: no poverty, zero hunger, good health and well-being, quality education, gender equality, clean water and sanitation, responsible consumption and production, sustainable cities and communities, reduced inequalities, industry innovation and infrastructure, decent work and economic growth, affordable and clean energy, climate action, life below water, life on land, peace, justice, and strong institutions, partnerships for the goals. So these are the 17 sustainable goals identified by the United Nations. And if AI is applied for solving problems of any of these goals, then this is called AI for social good. So now let me discuss about the main topic, multimodal information processing. So that multimodality is nowadays very common term. So multimodality means that you should not rely on only single source of data. So basically you have to rely on the multiple sources of data. So for example, our experience of the world is mostly multimodal. Like suppose you have to take a decision about an object, we do not only see the object, we used to hear the sound of the object, we used to feel the texture of the object, smell the odor of the object, and also taste the flavors of the object. And by combining information collected from multiple sensors, we used to collect the decision, we used to basically come up to a decision. So basically, that this is called the multimodal information processing, where we are not relying on a single source of data, but we are relying on multiple sources of data. So, that multimodal learning consolidates heterogeneous data from various sensors and data inputs into a single model. So basically, we are somehow collecting data from multiple sensors, and then we are somehow combining those information into a single model. The approach of training models on only single source of information, such as either text, audio or video, is commonplace, but there are very less number of techniques or tools available where information is fused, generated from multiple sources. But there is also a way to build models that incorporate multiple data types, like text or images at the same time, called multimodal information processing. So basically, multimodal information processing is having many applications. So just take an example of emotion recognition. So suppose you have to, you have to find out the emotion of a particular person. So you know that if you are simply relying on the textual description, maybe that is not enough. So you also have to see the facial expressions or the body movements of the person. So you have to, and then maybe you can better understand the emotional state of the speaker. So the emotion, so the the body language or the facial expressions or the audio tone can easily help you to understand the appropriate emotion of the particular person. So if because there are some ambiguity in certain sentences, so some sentences can have sarcasm as well. So like depending on the audio tone or depending on the facial expressions, you can better understand the communicative intention of the speaker. So for example, here there are two speakers, and you have the textual representations of the utterances, and now you have to automatically detect the emotion. Like you liked it, you really liked it, Joey is saying, and the Chandel is saying, oh yeah. So now, oh yeah, whether this is sarcastically said or this is basically a normal sentence, that can only be understood by the body language or the facial expressions. So this way, by analyzing not only the textual representation of the utterances, but by understanding the body language and the audio tone, we can better understand the emotion or the sentiment of the speaker. Similarly, in the second example, you can see, like suppose you are collecting tweets from the Twitter, okay, and you want to generate a summary. So this microblog summarization is very important during the disaster scenarios, because during the disaster scenarios, people stay connected with each other through social media platforms. So basically, what they used to do is that they used to upload many tweets in the social media, and now we can easily collect those tweets, and they through these tweets they used to show the current situation of the area. So like suppose there is a flooding, so they used to upload many images, or they used to write in social media about their current situation. So if and the physical connectivity is mostly lost, and people used to stay connected with each other through social media platform. So now suppose we are collecting these tweets, and now we want to generate a summary of these tweets. So in the first stage, we have to understand whether a particular tweet is informative or non-informative. So if the tweet contains some information, like the tweet is really helping, the tweet really contains some information, then this is called the informative tweet. And if the tweet is not containing any information, and tweet only has some empathy or the emotion sentiment in it, then this is not important for generating the summary, because our target is to generate a summary for the rescue team. So this summary will be given to the rescue team, and the rescue team can easily plan for the rescue operation by seeing this summary. So basically, in the first stage, we are classifying the tweets into two categories: informative and non-informative. So now, based on the image and the text, we are classifying the tweet into informative and the non-informative categories. And then in the second stage, all the informative tweets are used to for the summarization purpose. So, what are the benefits of multimodality? So, obviously, one benefit is that only a single modality or the single source of information is not always enough. Like I told you, that in real life also, whenever we have to take a decision about a object, we used to, feel the object, we used to hear the sound of the object, we used to see the object, we used to touch the object. So we used to use multiple sensors of our body to collect information about a particular object, and then only we take a decision about the object. So basically, that relying on multiple sensors can provide us more perspectives or provide us more information. And the fusion of multiple sensors can facilitate the capture of complementary information or trends that may not be captured by the individual modalities. So how multimodal learning works? So basically, you have to identify multiple sources. So you should have multiple sources of information. So it could be at least two. If it is multimodal information processing, then you should have at least two sources. And then there should be some layers of feature extraction. So by using some layers of, we have to extract some features, and then we have to somehow concatenate all the features, and we have to pass this feature through some layers, so through some shared layers, and then finally some classification or regression task will be solved. So we need at least two information sources, an information processing model for each source, and a learning model for the combined information. So we are identifying several sensors, and now from each sensor we are extracting some features. Then we are concatenating the feature vectors extracted from multiple sensors. We are concatenating them together, and then we are passing through some fully connected layers for solving the classification of the regression task. So in general, there are three types of information fusion techniques. One is called the early fusion or data level fusion, or referred to as the input level fusion, late fusion or decision level fusion, and third is called the intermediate fusion. So what is early fusion? So in the early fusion, as I mentioned, there will be multiple sensors. So we have to extract features from these multiple sensors, and then we have to combine the features together. And now this combined feature vector will pass through the model for generating the output. So here the fusion is done at the feature level. So you have multiple sources. So from each modality or from each source, we'll be extracting some features. So and then all those features are concatenated, and then this combined feature vector can be passed through the model for generating the output. So data features are first extracted from individual modalities before fusion, especially when the data sources have different sampling rates between the modalities. The assumption behind early data fusion is the conditional independence between multiple data sources. So somehow when you are fusing, we have to make sure that there is a synchronization. So like suppose we have the audios and videos and the utterances, we have to make sure that there is a for each timestamp we can fuse the features. So synchronization is very much needed for proper concatenation of the feature vectors. So the disadvantages of the early stage data fusion is that a large amount of data will be deducted from the modalities to make a common ground before fusion, and synchronizing the synchronizing the timestamp of the different modalities. Now in the second approach, this is called the late fusion or the decision level fusion. So here late fusion process modalities independently. So here we are not extracting features and not we are concatenating the features. Rather we are considering each sensor separately. So for each sensor we are building a separate model. Like for example, there is a sensor 1. We are extracting some features from sensor 1, and then we are passing these features through the particular model, and then we are generating some decisions. Similarly, for sensor 2, we are extracting some features, we are generating model 2, we are generating some decisions. Again, for sensor K, we are extracting some features, we are passing these features through model K, and we are generating some decisions. And finally, there is we are applying some majority voting or the weighted voting on the decisions, and there will be a final output. So late fusion process modalities independently, followed by fusion at a decision-making stage. This is beneficial when the modalities are significantly varied from each other in terms of sampling rate, data dimensionality, and the unit of measurement. So basically, we are extracting features from the individual sensors, and then we are passing them through some models. We are generating some outputs, and then at decision level, there is a fusion. So we are applying either majority voting or the weighted voting at the decision level, and accordingly the output is generated. So late fusion often gives better performance because errors from multiple models are dealt with independently, thus errors are uncorrelated. So basically, you know that we are for individual sensors, we are building individual models, and then we are simply combining the decision, or we are simply applying the majority voting or the weighted voting at the decision level. So now there is an intermediate fusion. So in the intermediate fusion, in a hierarchical way, we are fusing the information collected from multiple sensors. So like for sensor 1, we are extracting some features. Then from sensor 2, we are also extracting some features. Then we are combining those features. Now this combined feature is gradually combined with the sensor K. So in a hierarchical manner, we are combining the features. So the intermediate fusion is in a deep learning multimodal context is a fusion of different modalities representations into a single hidden layer. So we are extracting some features from the individual sensors, and then we are combining them in a hierarchical way. So first features generated from sensor 1 and sensor 2 are combined. Then this is gradually combined with sensor 3, and finally after sensor K. So the model learns a joint representation of each of the modalities. So different modalities can be fused simultaneously into a single shared representation layer, or this can be performed gradually using one or multiple modalities at a time. So basically, in a hierarchical manner, we are combining the features extracted from different sensors. And then in a hierarchical manner, we are combining the feature vectors. And finally, this combined feature vector is passed through some fully connected layers for generating the output. So the different modalities can be fused simultaneously into a single shared representation layer, or this can be performed gradually using one or multiple modalities at a time. The layer where different modalities are fused is called a fusion layer or a shared representation layer. So now, so these are the three different ways of combining information from multiple sources. So either we can go for the early fusion, where we are fusing the information at the feature level, or we can go for the the data fusion or the late fusion, where we are fusing the decisions taken by multiple models, or we can also go for the intermediate fusion. So now let me show you some applications of this multimodal information processing. So one application is in dialogue systems. So dialogue systems are nowadays very popular because we are regularly using the Alexa or Siri. So this Alexa, Siri, these are the examples of chatbots of the dialogue systems. So this building a chatbot is not very easy because it has several components, and dialogue act classification is one such component. So now I will show you how in dialogue act classification we can utilize the multimodal information. So this is the overall diagram of the dialogue system. So suppose user is saying something like, which restaurant can I book for 2 people for today? If this is the user's input, now first module is the natural language understanding module. So this natural language understanding module is having 3 components: dialogue act classification, intent classification, and the slot filling. So basically, that basically dialogue act classification means that we have to understand the type of the dialogue. For example, which restaurant can I book for 2 people for today? This is a question. So either we have to detect whether this is a question, or it is a statement, or it is a the open question, or it is a greeting. So what is the type of a dialogue? That is called the dialogue act classification. Now the second task is intent classification. So in intent classification, we need to understand the communicative intention of the user. So like, for example, which restaurant can I book for 2 people for today? So here the intent of the user is booking a restaurant. So intent classification means to understand the communicative intention of the user. So here the intention is booking a restaurant. And then finally there is a slot filling module. So slot filling means in order to extract some important information from the dialogue. So like, which restaurant can I book for 2 people for today? Here the important information are 2 people and today. So these are the 2 important slots present in the user's input. So now this is given as this is called the state information. The date, today, number of people, 2. This is given as a state information to the dialogue manager. And dialogue manager is basically mapping the state into action. So that state, depending on the state, it picks the appropriate action. So for example, the next action is asking the category of the restaurant, because before booking the restaurant, the chatbot should know what is the preference about the category of the restaurant by the user, because user has not specified that till now. That's why maybe the chatbot has to ask some additional question to understand the category of the restaurant. So the dialog manager is asking a question, the category. So there is a natural language generation module. So this natural language generation module will basically translate the asked category into a system response, and that response will be given to the user. So this is the overall dialogue system. So now, this is the overall dialogue system. So basically, that this is the end-to-end dialogue system. User is saying something in speech. There is an input speech. Now there is an automatic speech recognition module, which will, translate the speech into text. Now this is the ASR hypothesis. Now there is a spoken language understanding in the module, which will extract the important information like the domain, intents, and the slot values from the speech from this utterance. And then there is a dialogue state tracking. So this is basically all these domain, intent, and slot values will be given as a state to the dialogue policy, and the dialogue policy is basically a reinforcement learning based agent which will map the state into action. And finally, this action will be translated into system response by a natural language generation module, and the system response will be again translated into voice output by the text to speech module. So this is the overall end-to-end dialogue system. So it is a combination of many modules, and also each module is having many sub-modules. Like for example, spoken language understanding, this is a module, and it has 3 sub-modules: dialogue act classification, intent detection, and the slot extraction. So basically, we will discuss about the dialogue act classification in detail. So as I mentioned earlier, dialogue act classification means to understand what is the type of a particular dialogue uttered by the user. To identify the communicative intention of a speaker in a dialogue conversation classified into a predefined category. So suppose user is saying something. So what is the category of the utterance? What is the category of the dialogue uttered by the user is called the dialogue act classification. So there are different categories, like what kind of experience do you have then with the child care. So this is an example of a question. I think it is relate. This is an example of a statement. Just 1 minute. Yeah, am I audible?
Yes, madam. You're audible.
Yeah. My screen is visible, no?
Yeah, right.
Yeah. So Yeah, so basically dialogue act classification means you have to understand the category of the utterance of the user. So like there are many such categories. For example, you can see what kind of experience do you have then with the child care. This is a question. I think it is really, this is an statement. How about you? This is an open question. That's all right. This is an understanding. So we need to understand the what is the type of a particular dialogue. Primarily, we did a literature survey and we found out that all the works in dialogue act classification are mostly textual modality based. So they only utilize the textual representation of the utterance. But the non-verbal features like the tone feature or the facial expressions. So in which tone the person is talking. Like for example, okay, sure. So this okay, sure can be either agreement or disagreement. Like if you are very angry and you are saying okay sure, then maybe it is a kind of disagreement. But if you are sad and you are saying okay sure, then this is a kind of agreement. So these kind of sentences, it is a very ambiguous utterances. So it's very difficult to correctly understand the communicative intention of the user. So in that case, we can utilize the multimodal information. Like we can see the change of tone or the facial expressions to better understand what is the correct meaning, correct, current dialogue act of these utterances. So nonverbal features can provide useful cues to identify DAs, thus stressing the role of incorporating multimodal inputs into the task. So mostly in expressive dialogue acts such as greeting, thanking, apologizing, etc., speaker's emotion. So speaker's emotion can assist in recognizing communicative intention. And another observation is that emotional state of the speaker has also a substantial effect on the pragmatic content. Like if we can also correctly identify the emotional state of the speaker, so that can also help in correct identification of the dialogue acts. So what we have done is that we have proposed an attention-based multitask multimodal deep neural network for jointly optimizing the dialogue act classification and the emotion recognition task. So here dialogue act classification is considered as the primary task and the emotion recognition is considered as the auxiliary task. And our aim is to improve the dialogue act classification with the help of emotion recognition. So basically, but when we started doing research in this domain, we identified that there is no dataset existing. So there is no dataset which is having these three information like video, audio, and for tone we are relying on the audio signal. For the facial expressions we are relying on the video signals, and then we also need the textual representations of the utterances. So there was no dataset where all these three modalities are present, as well as each utterance is annotated with the dialogue act and also the emotion of the speaker. So we developed a new dataset which is called the multimodal emotion DA, EMOTIDA, with high quality annotations of dialogue acts, including emotionally aided cues for facilitating research in multimodal dialogue act classification and lead to a novel subtask, emotion aware DSE. So basically, we developed this dataset which is called the emotion aware dialogue act classification. So we have established that multitasking and multimodality boosted the identification of dialogue acts compared to a single task and unimodal DSE variants. So basically, that our main observation is that multimodality is helpful in improving the dialogue act classification, and also the multitasking like the emotion recognition is helpful in improving the dialogue act classification. So this is the dataset collection part. So we scan the literature for existing multimodal emotion recognition dataset, and we zeroed down to AIAMLCC and MAIL. So these two datasets are basically some multimodal emotion recognition datasets. So in these datasets, there are three modalities: the audio, video, and the text. and these data sets are already annotated with the appropriate emotion tags. But these data sets are not annotated with the dialogue act tags. So the switchboard corpus is a very important switchboard data set is a tag set is a very important tag set for dialogue act classification, which is having total 42 tags. So now from these 42 tags, we selected 12 most commonly occurring tags. Those were used to annotate the utterances of the emoted dataset. So we annotate each utterance of the emoted dataset by these 12 tags, which are greeting, question, answer, statement, opinion, statement, non-opinion, apology, comment, agreement, disagreement, acknowledgement, back channel, and the others. So these are the 12 tags. Each of the utterances is basically annotated with any of these 12 tags. So emoted dataset comprises of 1341 dyadic and multi-party conversations, resulting in a total of 19,365 utterances or annotated videos with emotion and DA tags. So basically, in our dataset, there are 1341 dyadic and multi-party conversations, total of 19,365 utterances, and each utterance is having the the emotion tag and the DA tag present. So each of the utterances contain 3 modalities: video, audio, and text. So you know that this is the, for example, speakers are A_4 Rachel, M_1 Chandler. So utterances adders don't snap this string. Well, I just checked our messages and Joshua did not call. So adders don't snap this string. So this is a dialogue act is disagreement and emotion is anger. Well, I just checked our messages and Joshua did not call. This is an example of a statement and emotion is sad. That's very amusing indeed. So here dialogue act is disagreement and the emotion is anger. And come on, pick up, here dialogue act is command and the emotion is fear. So basically this way each utterance is basically having 3 modalities: audio, video, and text. And we are annotating each utterance with the dialogue act and also the emotion class. So 48% samples are coming from the IMOCAP dataset and 52% samples are coming from the male dataset. And this is the overall speaker distribution. So like you know that in the emoted dataset, there is a this is some samples which illustrate how emotion can help in better understanding the dialogue act. Like for example, Monica is saying, "I can't believe it, you gauged a hole in my dinghy floor." So here, if you know that the emotion is anger, then you can easily understand that the dialogue act is disagreement. Now, like, well, you know, I appreciate you coming over and talking to me. I mean, it definitely helps. So here, if you know emotion is sad, then you can easily understand that the dialogue act is basically the acknowledgement. So basically, these examples illustrate the importance of having emotional information while deciding the dialogue act of an utterance. The presence of emotion in the dataset caters the models with the ability to use additional information while reasoning about the dialogue act. So basically, these examples illustrate how emotional information can be helpful in detecting the dialogue act correctly. So like here in this particular slide, we have shown some examples which illustrate how multimodal information can be helpful. Like in both the examples, there exists inconsistency between modalities, which acts as a strong indicator that multimodal information is also important in providing additional cues for identifying the dialogue acts. Like first example, you can see fine. Then you tell Roger because he was really looking forward to this. So now from this textual representation, you can see it looks like this is an agreement or the opinion. But if you see the audio, then it looks like it is a commanding tone, and the video is showing the furious. So then the correct DA tag is basically the command. Now, if the utterance, suppose in the second example, the speaker is saying that's very amusing indeed. So now the text, if you see only the text, it looks like this is an agreement. But if you see the audio, then it is a sarcastic tone, and if you see the video, then it is showing slight anger. So the true dialogue act category is basically a disagreement. So after combining the information from multiple modalities, we can understand that the true dialogue act is basically a disagreement. So the availability of complementary information across multiple modalities improves the model's ability to learn discriminatory patterns that are responsible for this complex process. So these examples illustrate how multimodality is helpful. So as we are considering information from multiple sources, so basically somehow we are able to correctly predict the the dialogue act. Because if we are relying on the text, then there is a misunderstanding. But the audio and the video, by considering information collected from these different modalities, we can better understand the communicative intention of the speaker. So now, so basically, this paper got published in ACL 2020. So ACL is A-star conference in the field of natural language processing, and you know that. So next, let me now discuss about the model. So you know that there are as we have three modalities: text modality, audio modality, and the video modality. So we are somehow extracting features from all these three modalities. So for the textual modality, we are using the globe embedding. So basically that we have the transcripts available for each video forms the source of the textual modality. So we are using the we are using the pre-trained globe embedding of dimension 300 to obtain the representation of the words. So basically we have the transcripts generated from the audio signals, and now we are using the pre-trained globe embeddings of dimension 300 to obtain which is the representations of the words. So word embeddings of each word are concatenated to obtain a better final utterance representation. Now we also extract some audio features. So audio features are extracted from a tool called the OpenSmile. So OpenSmile is an open source software. So by using OpenSmile, we are extracting some audio features of dimension 256 for each window. The final audio representation for each utterance is obtained by concatenating the feature vector for every window. So there are multiple windows in the audio data. For each window, we are extracting some feature vector, and then we are concatenating the feature vector, and that is the final audio feature representation. Similarly, we have the video features. To elicit visual features, a pool layer of an ImageNet pre-trained ResNet 152 image classification model has been used. The visual representation of each utterance is obtained by concatenating the 4096 dimensional vector for every frame. So basically, we are having three textual modality representations. So basically, we use three BILSTMs. Why BILSTMs? Because the context is very important. So previous words and the next words are very important. That's why you're using the BILSTMs. So one BILSTM learns the dialogue act features tuned in accordance with the emotion features. Second learns features for the emotion recognition task regulated by the learning of the dialogue act features. And a third BILSTM learns private features for the task of dialogue act classification not influenced by the emotions. Similarly, we have audio and the video features are also passed through some fully connected layers to learn attention of different variants. So basically what we are doing is that we are applying different types of attentions: self-attention, intermodal attention, and the inter-task attention. So self-attention is helping us to focus on a part of the text. Intermodal attention means that given the text, we can focus on a part of the audio, or given the video, we can put focus on a part of the audio. So this way, this is helpful. And we also can have the inter-task attention, where based on the emotion task, we can put focus on some part of the dialogue act. So basically what we are doing is that we are fusing the attention. So 13 different attention outputs for different tasks and modalities are computed from this corresponding attention scores. And then mean of different attention outputs in heading combinations are computed to obtain final representation for each of the modalities and tasks. And then we appropriate weights are learned to combine these above representations to obtain final sentence representation for each of the tasks to be optimized jointly. And finally, we generate a final, the sentence representation for the dialogue act, which is the weighted average of these attention vectors, and also one sentence representation for the emotion classification, which is again the multiplication of these different attentions. So now these sentence representations are passed through two separate channels. You can see in the final layer, there are two separate channels. One channel is for dialogue act classification, other channel is for the emotion recognition. So this sentence representation is passed through this channel for classification of the dialogue act, and this sentence representation is passed through this particular channel for identifying the emotion classes. And the errors are computed from both the channels and then combined together, and then are back propagated jointly to successive prior layers of the model to learn joint features of both the tasks. So now you know that we have experimented with both dyadic and the multiparty conversational settings. In addition to the whole data set for the multitask framework along with different modalities. So, we did a ablation study because there are three modalities: text, audio, and video. So basically, that there are, we did a ablation studies of this modality. So we first took results with the individual modality, then the bi-modality, and finally the tri-modality. So we have the results with only text modality, only with audio modality, only with video modality, then text plus audio modality, audio plus video modality, text plus video modality, then text plus audio plus video modality, and then maybe in place of considering emotion as an additional task, we can also utilize these emotional features as additional features. So basically, you can see that we have now we have taken results on different setting. In dyadic setting where there are only two speakers, in multiparty space setting where there are multiple speakers, and also the overall by combining all utterances together. And then there are two settings: either we are considering on the dialogue act classification as a single task, or sometimes we are also considering the emotion recognition as an additional task. So, results indicate that when you are considering emotion recognition as an additional task, then there is a improvement in the performance. And individually, the textual modality is providing the better result. But when we are adding the video into this, there is a 7% improvement. So individually, text is giving 50.22 F1 score. But when you are adding video modality into this, we are getting 57.96. But somehow audio modality is not very much helpful, because maybe as we are using the pretend model like open smile, and the open smile is maybe giving us some suboptimal features. That's why by adding the audio modality, we are not able to improve the performance. So our observation says that multitasking framework performs consistently well compared to a single task DSC variant. It was beautiful. True level is agreement. Multitasking is also saying agreement. The single task is saying others. Then why is she still single? Newark is full of men. Why has not she married? Here true level is others. Multitasking is statement, and single task is question. So this is the kind of error analysis, and you can also see some ablation studies of like feature level fusion is giving us the F1 score of 48%, but when we are doing the multitasking, then we are getting 57.97. And on the right hand side, you can see the heat map. So when we are only solving the DSC task, for example, for the sentence, oh yes, yes, I am, you can't stop me. So here, when we are solving all the DSC tasks, the focus is on the yes, yes word. But when you are solving the two tasks, like dialogue act classification and the emotion recognition, the focus is on the words like can't and the me, etc. So means we are able to focus on the correct sentences, correct words. So yes, so any question up to this point? So,
no, madam, there are no questions.
So also like participants are in some other link, because I can only see 9.
Yeah, we are actually live streaming it on YouTube. So there are near about 212 participants watching on YouTube.
Okay. Yeah, I do not see them here. Okay. So I just need 2 minutes break, okay? Then I will
Okay,
continue.
madam. Okay.
Yeah.
Okay.
So is my screen visible?
Yeah, it is visible.
Okay, so now coming to the second application. So second application is on Twitter. So we similar to the previous case, like where we are trying to identify the communicative intention from the user's utterances. In the second task, we are trying to understand the communicative intention of the tweet. So which is called the speech act classification of the tweet. So you know that speech act classification helps in understanding the communicative intent of a speaker. This holds true for discussion in any fora, including social media platforms such as Twitter. Thus, Twitter classification typically helps in determining the communicative intention of a tweeter. So, for example, my dream is to have my boat returned to me. Rasat said, I have been wishing to die every second after my boat died. So, this is an example of an expression. Like, you should direct just a little bit of your criticism towards the role the Israelis play. This is an example of a suggestion. Like, why the league win title in the gallery? This is an example of a question. So to understand the communicative intention of a tweet is basically called the Twitter classification. So, again, we have done a thorough literature survey and we identified that most of the Twitter classification works are utilizing only the textual modality. But in many cases, whenever we are whenever users are writing the tweets, they can also upload the images, or they can also post some emojis as a part of the tweet. So these non-verbal cues like emoji in tweets can provide useful information to the identified tweet tags, thus stressing the role of incorporating multimodal inputs into the task. So that and also another important thing is that if we can somehow understand the emotion and the sentiment of the speaker, then also we can better understand the tweet tag classification. For example, a question or statement is associated with anticipation, and opinion is often associated with anger or disgust. Mostly in expressive tweet acts such as expression, threat, request, threat, etc., Twitter sentiment and emotion can assist in recognizing communicative intent. So basically here Twitter classification is our primary task, and the emotion recognition of the sentiment analysis of the speaker are our auxiliary tasks. So we have proposed an attention-based multitask, multimodal deep neural network where Twitter classification is our primary task and the sentiment and the emotion recognition are our auxiliary tasks. So we have created a new dataset which is called the multimodal emotion TA or EMO-TA with high quality annotations of tweet tags, including emotionally aided cues for facilitating research in multimodal tweet tag classification and lead to a novel subtask, sentiment and emotion about tweet tag classification. So basically we are developing a dataset where each tweet is having its tweet tag, and also the emotion and sentiment information are also associated. So there was no such dataset existing. So we have established that multitasking and multimodality can boost the identification of tweet tags compared to a single task and unimodal TSC variants. So we have established that that multitasking, like when we are solving the three tasks together, tweet tag classification, sentiment analysis, and the emotion recognition. So the auxiliary tasks like emotion recognition and the tweet tag classification can help in improving the tweet tag classification. And also, if we can consider the emoji as additional modality, then that also helps us in correct identification of the tweet tags. So again, there was no such dataset existing where all these information are present, like the tweet act, emotion, sentiment, and also emojis. So scan the literature for existing sentiment analysis and emotion recognition dataset. So we zeroed down to Cerebral 2018 dataset. So this dataset is already annotated for if their dataset is not annotated for their corresponding sentiment and the tweet act tags. So this dataset is already annotated by the emotion tags. So, but this dataset is not annotated with the tweet tag tags or the sentiment tags. So we have used 7 tweet tag categories for annotating the emo-TA dataset as opposed to 5 and 6 TA categories. So we have utilized 7 tweet tag categories like statement, expression, question, request, suggestion, threat, and others. These 7 classes we have utilized: statement, expression, question, request, suggestion, threat, and others. So a subset of Cerebral 2018 dataset amounting to 6810 tweets were selected to create emo-TA dataset. So basically we have selected 6810 tweets from the emo-TA dataset and then we annotated them manually by the 7 tweet tag tags. And then for the sentiment annotation, we have utilized a semi-supervised approach. So the IBM Watson sentiment classifier, which is an open source API, is used to classify each of the tweets into 3 classes: positive, negative, and the neutral. And this dataset was already annotated with the multi-level emotion labels, so which contain 11 multi-level emotion categories. So this is an example. So emo-TA dataset is having 6810 tweets with the corresponding gold standard tweet tags and the multi-level emotion tags. So like for example, you can see we are going to get city in the next round for a revenge. So here the tweet tag is basically threat. And also, the emotion is anger and the sentiment is negative. Then, the Ryan Gosling and Eva Mendes finally: be joyful and funny, don't boss, don't argue, do everything with kids, go to mini car trips, focus on love. So here the tweet act is suggestion, emotion is joy or love, and sentiment is positive. So here you can see the distribution of the labels. Like there are mostly negative labels, few positive, and the few neutral labels. So this is the distribution of the classes. So then we have proposed this architecture. So basically, input to it. Then we have that from the input to it, we are extracting some features. So now the tweet is having two modalities: textual modality and the emoji modality. So you are using for the emoji modality, there is the emoji to bake, which is generating vector representations of the emojis. And then we are passing through some bile STMs, and then this query key and the value for putting some attentions. So basically, you can see that the input to it is passed through some feature extractors, and there is also some shared layers. Some features are shared across these three tasks. So there are three tasks: sentiment analysis, emotion recognition, and the tweet tag classification. These are the three tasks. So there are some shared layers, and there are some private features. So we are combining them together. The private features and the shared features are combined together, and then we pass them through some fully connected layers for classification. So there is a separate layer for the sentiment, separate layer for the tweet act, and separate layer for the emotion recognition. So this is a fully shared, and this is a shared private model. And then that so basically we are somehow back propagating the errors coming from these three different channels. So experiments were conducted in two different settings: 5 class and the 7 class classification setting. And multitasking framework performs consistently well compared to the single task Twitter classification variant. And different modalities improves the unimodal TSC baseline significantly. So basically, you can see that sometimes we are solving three tasks together: Twitter classification, sentiment analysis, and emotion recognition. And then we are also solving two tasks together: TSC plus ER, TSC plus SA. And also that we are using different combinations of the input, only text and also text plus emoji. So results indicate that adversarial learning is most useful. So we are getting the F1 score of 78.16% in case of adversarial learning, and also accuracy of 80.32. So, these are the two applications. So the other application is that that we are also working on developing a chatbot. So we can also we are also working on developing a chatbot which can help, which can behave like a sales chatbot. So in a typical, mainly there are two types of chatbots or a dialogue system. So one is called the task-oriented dialogue system, and another is called the chit-chat dialogue system. So task-oriented dialogue system means, suppose you are assigning a task to a chatbot, and the chatbot is trying to solve the particular task, then this is called the task oriented dialogue system. And suppose there is a chit chat, like if you are simply discussing with the chatbot on a particular topic, then this is called a chit chat dialogue system. So in a typical task oriented dialogue system, end users convey their task goal to dialogue agent by either specifying their goal components or informing agents requested task related queries. And then basically the somehow the agent tries to solve this particular task. So basically, however, in real world, it seems improbable that end users will always have a predefined task goal, which is called a dynamic goal setting, a goal that exactly corresponds to one of the underlying databases, which is called the cooperative and persuasive behavior, and only takes data for conveying their task goal, adaptability to multimodal input. So basically, that in some domains such as e-commerce, Users demand or prefer to illustrate their task specification through images. So basically, you know that in some, suppose user is specifying some specification, so maybe some always the textual input is not enough. The user can also express the requirements through images. So basically, the multimodal inputs are all sometimes useful. That maybe the users may not express all the specifications through text, but users can also show some images. So a goal that exactly corresponds to one of the underlying databases is called cooperative and the persuasive behavior. So basically, this is the proposed architecture. So basically, you can see that suppose user is showing something. So there is a natural language understanding module. So basically, you know that we have this intent and the slot labeling module. So we have this intent and the slot labeling module, or the sentiment and the image information module. Now there is a natural language understanding module which will try to identify the important information from the user's utterance. Then this state is given to the dialog manager, and the dialog manager will basically map the state into action. So now there is a discrepancy manager, and then there is a goal persuader. So the discrepancy manager will try to understand the discrepancy in the action. So like for example, you know that whether you know that what is the with suppose you know that you agent is trying to say something, whether there is any discrepancy or not. So that has to be, you know, somehow understood. So this is the our proposed architecture. So our novelty is this incorporation of these two things: discrepancy manager and also the goal persuader. So basically, you know that we can the discrepancy manager is able to understand whether there is any discrepancy from the initial goal or not. So maybe user has specified a particular goal, but now there is a discrepancy in that particular goal. So that the goal persuader can be invoked, and the goal persuader can help in understanding the alternative goal. So there was no such data set in this particular domain. So for the sales chatbot, so we have also created our own data set. So and here it is a multimodal in nature. So basically now the user can specify the specifications not only through text but also through images. Like suppose user is saying, "Hi, can you help me in buying a mobile?" Agent is saying, "Sure. What kind of features do you want in your phone?" User is saying it should have 32 GB internal RAM and at least 13 MP camera quality. Agent is saying, is it all features that you need? User is saying, and color should be gold. Agent is saying, congrats, there is a perfect phone for you. You should buy this Samsung Galaxy C7. It has 16 MP camera quality and 32 GB internal capacity. User is saying, no, I do not like this color. I want something in this color. So basically, user is not aware of the rose gold color. So user is simply showing an image, and now the agent has to understand the color name from this image. So the agent confirming, can you please confirm that you want phone in rose gold color? User is saying, yes, you are right. I love this color. Agent is then saying, then surely you will like Lay Max 2 by Lay Eco, which contains 32 GB internal RAM with 21 MP camera quality. So the user is saying, yes, it is nice. How much does it cost? Agent is saying it costs only 350 euro. Now the user is saying, oh yeah, it is too costly for me. I need a phone within 250 euro. Agent is again searching, and then agent user is again showing some alternative phone. Now user is happy with the phone and user is going to buy this. So you can see in many cases either user or the agent is showing some images of the phone. So this way this data is multimodal. So the domain is basically electronics. Task is the phone information or the phone booking. Number of dialogues are 1000. Number of utterances is 8335. Number of samples in the knowledge base is 2697. Number of attributes of the slots in knowledge base is 18. And the examples of the attributes are brand, RAM, color, etc. And the image categories are color, brand, style, shape, type, etc. So, you know, this is the thing that our this virtual agent is having many applications. So, virtual agent can be used in for selling purposes. Then in customer care, representatives are mostly replaced by the virtual agents. Then we can also have some virtual agents in the healthcare domain, or we can also have the virtual agent as the counselors. So the virtual agents has many applications, and and basically that now let me discuss about some applications in the healthcare. So we are also trying to develop some virtual doctors. So basically what happens is that in the big hospitals, whenever a patient is visiting a big hospital, in general patient is visiting to a receptionist. So, disease diagnosis is the primary and the crucial stage of any medical treatment process. So, the world falls short of 7.2 million medical workers, 30 millions by 2030. Most of the countries across the globe have only 0.01% or to 0.1% doctors. A survey shows 35% US adults had utilized self-diagnosis tools before consulting with doctors. So basically what happens is that suppose the patient reports to the receptionist. So now the receptionist used to guide the patient to a particular department. Like a big hospital is having many departments like cardiology, gynecology, dental, orthopedic, etc. So that depending on the self-report, like the patient used to report what the problems he or she is suffering from. Now, based on the self-report, the receptionist used to guide him or her to a particular department. Now, in a particular department, there are many senior doctors and there are some junior doctors. So these junior doctors are responsible for symptom investigation. So they used to ask some additional symptoms from the patients, and then they prepare a report. And now this report is given to the senior doctor, and senior doctor based on this report used to take the decision. You used to basically diagnose the disease and prescribe some medication. So basically, that now the idea is that can we somehow replace these junior doctors by a virtual agent? So now this virtual agent will do the symptom investigation, and then it will generate some report, and the report will be validated by the senior doctor, and the senior doctor will prescribe the medicine or also will diagnose the disease. So, like that basically the efficient time utilization of doctors and early diagnosis are two motivations for disease diagnosis assistant. So, for example, patient is suppose saying, "Hi, I have been suffering," and here another advantage is that when patient will when during the symptom investigation, maybe some symptoms, the symptom names patient is not aware of. In those cases, patient can also show some images, and from those images, the system, the virtual agent can easily extract the symptom name. So, like suppose the patient is saying, "Hi, I have been suffering from fever for a few days. Also, something happened in my mouth. Please see to this." Now the agent is saying, "Did you recently vomit?" So the patient is saying, "Yes, I vomited yesterday." Now now this agent is saying, "Do you have eye pain?" Patient is saying, "Yes, I am feeling so." Now this virtual diagnosis assistant is saying, "Have you observed any skin rash in your body?" "I am not sure, but please see to this." So finally, by considering all the responses, the agent can generate a report. The patient suffers from the following symptoms: fever, mouth ulcer, vomiting, eye pain, and skin rash. The most likely disease is erythema multiforme. The images are shown below. Now, from this report, we can easily that this report can be given to the senior doctor, and the senior doctor can easily verify the disease and also can prescribe some medication. So basically, this is a very challenging area. Developing some virtual doctors, no, it's not very easy. Again, dataset creation is very challenging. Dataset creation of this particular conversational form, which can also have the images of some symptoms, it is very challenging. So I have one PhD student, Abhishek Dixit. So he is Abhishek Tiwari. So he is a Prime Minister Research Fellow. So, Prime Minister Research Fellowship is a very prestigious fellowship. and he received this fellowship by writing this proposal on the virtual doctors. And now we are working on various problem statements like knowledge infused context driven disease diagnosis. So how context is helping. So like for example, this virtual agent will not have any medical knowledge, so we need to somehow provide some medical knowledge to the virtual agent. So basically this medical, so now we are working on knowledge infused context driven dialogue assist disease diagnosis. Then symptoms are known by their companies. There are many symptoms and there are some common symptoms also. So these common symptoms are always associated with many diseases. But so if we only see the single symptom, we will not be able to understand the disease. So we always have to see the associations between the symptoms. And by seeing the associations, we can easily infer the disease. Then multimodal automatic disease diagnosis. So as I mentioned, that in some cases, maybe the patients are not aware of some symptom names, the medical names of the symptoms they are not aware of. So they can simply show the images, and from the image itself, the patient can easily understand the symptom name. The agent can easily understand the symptom name. Now, they're learning from failures. Diagnosis assistant that also learns from unsuccessful diagnosis. So one important, doctors always learn from failures. So in many cases, doctors fail, and they used to learn from these failures. So can you somehow infuse this learning from failure capability inside a virtual agent as well? So humans learn a task through both successful and unsuccessful attempts in real life. So you need to assess the failed attempt, knowledge, and previous experiences. So now towards the multimodal automatic disease diagnosis virtual assistant. So in real world, when we consult with doctors, we often report and describe our difficulties or symptoms with visual aids. In fact, many people are unacquainted with several symptoms such as mouth ulcers or the skin growth. So our task is that somehow if we can sometimes if you can users can express their problems with images. So symptom image aided symptom investigation diagnosis. So dialogue context aware symptom image identification. So basically what we have done is that we developed a multimodal disease diagnosis virtual assistant using hierarchical reinforcement learning and dialogue context aware symptom image identification, and also multimodal diagnosis dialogue data. So basically these are the three our contributions. So we developed a virtual assistant which can also extract information from the images, and for that we have developed a dialogue context aware symptom image identification module. So this image identification module is not only extracting relevant features from the images but also from the dialogue context. And also we have generated a multimodal diagnosis dialogue data, because when we started doing research in this particular area, we saw that there is no data set existing. So we curated our own data set where patients have also expressed their concerns through images. So this is our overall architecture. So basically controller is our receptionist. So controller basically decides about the department. So each department is having a separate policy. So each department, for each department there is a separate policy. So and there is this multimodal diagnosis state tracking. So here there are two modules. One module is basically responsible for extracting symptoms from the textual representation, and the other module is basically extracting information from the images. And that way, that way the state is generated. There is a disease classifier which is classifying the disease based on this combined information. And finally, some report is generated. So this is our, the proposed architecture for natural language understanding module, which comprised of two main modules, namely intent and symptom module, and the context aware symptom image identification. So we are extracting features from the image DenseNet, we are extracting features from the images through DenseNet, and also clinical BioWart is used for extracting the image features. Then we are concatenating the visual features and also the image text features, and this concatenated feature vector is passed through softmax layers for extracting the the symptom information. So, this is the data set that we have prepared. So, number of dialogues are 1,500. Number of utterances are 6,936. Utterance tags are intent, symptom, image information. Average dialogue length is 4.62. Number of intents are 2. Number of diseases are 90. And number of symptoms are 266. Number of visual symptoms are 17 plus 3. Total number of symptom images are 1805. Number of multimodal utterances are 725. So these are the some of the symptoms which can have the signs. Like we have a the collaborator in AIMS Rishikesh, Dr. Meenakshi. With her help, we identified these 20 symptoms which can be expressed using images, like the skin imitation, mouth ulcer, skin growth, eye redness. All these, all these diseases can be expressed using the images. So, like suppose the patient is saying, "Hi, I have been suffering from fever for a few days. Also, something happened in my mouth. Please see to this." So then the patient is showing some image. Now the agent is asking, "Did you recently vomit?" "Yes, I vomited yesterday." "Do you have eye pain?" "Yes, I am feeling so." "Have you observed a skin rash in your body?" "I am not sure, but please see to this." So then again the patient is showing some image. The patient suffers from the following symptoms: fever, mouth ulcer, vomiting, eye pain, skin rash. The most likely disease is erythema multiforme. The images are shown below. So this dataset is called VIS MDD dataset. So here you can see that that we are developing many symptom image classifiers: CNN, Inception V3, then DenseNet 121, DenseNet 161. So we have developed different models, and then also there is a we have also shown that if we can consider the dialogue context, that also helps in correct identification of the symptom names from the images. So we are developing a context aware image identification module, and we have shown that somehow dialogue context helps in proper identification of the symptom name from the images. So when we are considering the context window of 3, we are getting the highest effort score of 88.24%. So on the right hand side, we can show the performance of different dialogue diagnosis agents. Our proposed model outperforms all the baselines and the state-of-the-art model across all evaluation metrics. So you can see we are evaluating in terms of diagnosis success rate, dialogue length, average match ratio, disease classifier accuracy, etc. So that we are improvement over unimodal baselines, etc. of the model. So we have seen that introduction of multimodality not only helps in basically introduction of multimodality helps satisfaction. So like if when users are when users are able to express their sense concerns through images, they feel more satisfied. So we have computed the human satisfaction, and this is much higher in case of multimodal scenario. So then there is a positive correlation between diagnosis success rate and dialogue length. So basically, that somehow if we can increase the dialogue length, then there is an increase in the success rate. And yes, dialogue context helps in identifying patient, provider symptom images, importance of context window. So now let me discuss about some other applications of this multimodal information processing, which is on complaint detection. So nowadays we are mostly purchasing products through different social media, through different online platforms, and then it's like Amazon, Flipkart, Myntra, Meso, etc. And now if we used to write the complaints in the in the feedback form. So like we can write the complaints in some blogs or in Amazon reviews. There is a review pop-up review blog where we can also write our complaints. So complaining is a speech act used to express a negative mismatch between reality and expectations towards a state of affairs, product, organization, or the event. So basically, that an individual's emotional state has a significant impact on the complaint expression, since emotions generally influence any speech act. So basically, that the automatic classification of complaint text in natural language is of extreme significance for linguists to acquire a better grasp of the specific context or purpose. So basically, there is a difference between the sentiment and the complaint. So that maybe the sentiment is negative, but it may not be complaint. So complaining means that there must be a mismatch between what you expected and what is the reality. So always all the negative sentiments may not have a complaint. Like I love boots. Shame you are introducing a man tax of 7% in 2018. So yes, this here the sentiment is negative. Similarly, basically here the sentiment is negative and the complaint is also present. But you suck here. The sentiment is negative, but it is not of complaining type. So there is a basically basic difference between the complaining and the sentiment. Hello, sir. हाँ 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 अच्छा सर आतिफ सर एक्चुअली ना मेरा ना टॉक चल रहा है सर So, hello.
Yes, madam. So there are a couple of questions which have been posted by the participants on the YouTube. I have posted them on the chat box.
Okay.
Yeah. So the first question that has been posted is that whether there is a feature extraction similar to text NLP for video.
Yeah. So I told you. So for the videos, what you have to do is that you have to first identify the keyframes, and then from each keyframe you have to extract each keyframe is basically a kind of image only, and now from each image you have to extract some features. Okay. So basically, from a video is nothing but the collection of many frames. So from this set of frames, you have to extract the keyframes by some algorithm. You have to extract some keyframes, and these keyframes can be passed through some some image recognition modules like ResNet or the DenseNet, and you will be able to extract some features from these images. Okay, that way you have to process the videos. Now the next question, how the accuracy of the diagnosis varies between invasive and non-invasive mode of treatments. How can you identify the fake responses? Yes. This is a very good question. So so basically that task we have not done yet. So we are relying that we are considering that whatever patient is saying is correct. So patient is providing us some information, and all this information are basically the correct that we have understood. So we have not identified the fake and the non-fake responses. Okay, you are very much correct. Like when we are a chatbot is discussing with the patient, maybe some responses could be fake, some responses will be non-fake. So we have not considered that some responses can also be of fake kind. We have considered that all are genuine. Yeah, so this is a very good question. In future, we would like to introduce this module as well. What is the level of accuracy in the diagnosis, and how can we identify the wrong responses? Yes, so basically wrong responses means that suppose the agent is keep on asking many questions, and some questions are irrelevant as well. Okay, so maybe the agent is asking you some about some symptom information which are not somehow related to the disease. So then there is a it's a kind of a mistake by the agent. So yes, so that is the success rate. So we are not only measuring the success rate, but also average matching rate, average matching rate too. So this average matching rate is calculating how many symptoms are matching. Like suppose agent is asking you say questions about some symptoms, how many of these symptoms are actually matching with the original set of symptoms associated with the particular disease. So this is we have the training data. In the training data, we know the actual disease and what are the symptoms associated with that original disease. And now the agent is asking some symptoms. So how many are matching? That we are somehow measuring by the average matching rate. So is it okay? Fine.
I think there are no more questions in the chat box. So, so on behalf of the organizing committee, I convey my deep regards and hearty thanks to our eminent speaker, Dr. Sriporna Saha, for providing a practical exposure to effective smart systems, tools, and its related applications in the field of multimodal information processing. So with that, madam, we are going to present a small token of appreciation to our speaker. Madam, is this visible?
Yes, yes. Yeah, many thanks. Yeah, thanks. Thank you so much.
So with that, we come to the end of our session, today's session, and we'll be joining tomorrow at the same time. So thank you, madam.
Thank
Once
you.
again.
Thanks a lot. Thanks a lot for inviting me in this occasion. Thanks a lot.
Thank you.
Thank you.
So we're going to post the feedback link on the YouTube chat box for the participants.